Welcome to this Maths Made Easy video on trig identities and approximations. And to start with, we're going to show how we derive two new identities. And to do that, we make use of an already established identity. And that's the fact that sine squared theta plus cos squared theta is 1. We can now use this identity to obtain two more identities. And the way we obtain these identities is dividing through by sine squared theta and then dividing through by cos squared theta. So our first identity here, we're going to obtain by dividing by sine squared theta. Okay, so if we divide across here by sine squared theta, what I'm going to obtain then is sine squared theta over sine squared theta. Moving along now to the next term, this cos squared theta, if we divide that by sine squared theta, then we can simplify our results in one moment. So we just write everything in full first. So this is over sine squared theta. And again here, make sure we divide the 1 by sine squared theta. Okay. And if we simplify this result here now, well, sine squared theta over sine squared theta, that simply gives us 1 here. Okay. Anything over itself again will give us 1. Cos squared theta over sine squared theta, well, that's the opposite now, or the reciprocal of tan squared theta. So in that case, if that's the reciprocal of tan squared theta, that's going to be 1 over tan squared theta, giving us cot squared theta. So that's plus cot squared theta. And finally here, this is the reciprocal of sine squared theta, which means this is cosec squared theta. Cosec squared theta. And we've obtained our first of our new identities there. So now let's have a look at the second identity then. And this identity is obtained by dividing by cos squared theta. So if we divide across by cos squared theta then, what we've got here is sine squared theta over cos squared theta. We're then going to have cos squared theta divided by cos squared theta. And finally, again, don't forget the 1 here. We need to make sure we also divide that by cos squared theta. And now all we need to do is simplify each result as we go. So sine squared theta over cos squared theta, that will simply give us tan squared theta there. Cos squared theta over cos squared theta, similar to what we did here, that will just simply give us 1. And finally, 1 over cos squared theta, so this is the reciprocal of cos squared theta, which we know is sec squared theta. And that's now our second of our two new identities. Now moving on to our small angle approximations. And what we're looking to approximate here is sine theta, cos theta, and tan theta. And we're looking to do this when theta is small. So what do we define by small? Well, small is defined here as being less than 1 in radians. Okay? So we're looking to approximate sine theta, cos theta, and tan theta. Okay, and remember, theta here is measured in radians, and we're looking at a value being less than 1 in radians for theta. So what are these approximations? Well, let's give the results first. So sine theta approximates to theta. Cos theta is the most complicated of the 3 approximations, and this approximates to 1 minus a half of theta squared. And finally, the approximation for tan theta, again, nice and straightforward. This approximates to theta. So we've got our 3 approximations here. So the question is, why would we use these approximations? We use these approximations for complicated functions where it may be difficult to compute them with standard methods. These expressions also extend to multiples of theta. However, the product must be less than 1. So writing out the extension here for multiples of theta, in this case sine of n theta here, this approximates to n theta. Okay. For cos of n theta, this approximates to 1 minus a half of n theta squared. So n theta squared. And then finally again, for tan of n theta, Again, this approximates here to just like we had with sine of n theta to n theta there. Okay, and just remember the product here must be less than 1.